Welcome everyone to our Green SE research group. My name is Massimo Aliotto and I'm a professor at the National University of Singapore. I'm truly delighted to share the recent advances in backscattered software-defined transmitters enabled by our research, which enables flexible coverage of most common wireless communication standards at best-in-class power and energy per bit in software-defined radios. Ray Wan will now share the details of the innovation introduced in this chip.
Hello, this is Ray. Currently, wireless transmission typically takes a major portion of power budget in distributed sensor nodes. Backscattered transmitters help push down the transmission power to microwatt level, as we have demonstrated on silicon in the past few years for 2.4 GHz standards such as Wi-Fi and BLE. Backscattered transmitters simply reflect and modulate the incident wireless power sent by an external source toward the receiver, pushing down power by removing on-chip active RF components such as power amplifier. However, most prior backscattered transmitters typically support only a single wireless standard and hence require device replacement if protocol updates or upgrades are needed. In turn, this limits the device lifespan and disloads the deployment of new or proprietary protocol. On the other hand, conventional software-defined radios offer high level of protocol flexibility at the cost of 3 to 4 orders higher energy per bit. In this work, we introduced backscattered software-defined radio architectures, enabling flexible choice of the wireless standard, the ability to update and upgrade the protocol over the entire lifespan of the device, while keeping energy to just a few tens of picojoule per bit. The proposed architecture is based on a digitally controlled oscillator that supports all basic modulations such as PSK, FSK, ESK, and the adjustable frequency phase, jitter, and power. This will minimize the energy per bit for a given standard jitter requirement, eliminating the traditional energy-hungry DAC in software-defined radios. To this aim, an on-chip low-energy embedded FPGA controls symbol generation directly in the time domain, carries out digital processing for flexible MAC layer and part of physical layer implementation.
Overall, this backscattered software-defined transmitter enables a power consumption that is at least 2 orders of magnitude better than prior art in software-defined radios. In addition to this very unique flexibility, reusability, and upgradability, the proposed backscattered software-defined radio transmitter can push power down to 1.5 microwatts, which can be provided, for example, by a coin cell battery for more than 20 years while transmitting continuously, or by an off-the-shelf 3x3 square millimeter solar cell at 500 lux, which corresponds essentially to indoor light. This ultimately enables ubiquitous connectivity in any smart object and silicon system in spite of the very limited power budget. Flexibility also supports higher manufacturing volumes for better economy of scale, stronger supply chain resilience, and reuse of silicon dies across applications, yet at a very limited power budget. Thank you for watching. Feel free to explore more in our Green SE website and follow us through our social media channels.